Today's video is sponsored by Native Sons Goods, makers of premium quality guitar, bag, and camera straps, handmade in Albuquerque, New Mexico. Check out their website to order your own custom creation and play in style. And remember, when you support my sponsors, you support this channel, and I sure appreciate it. Hey, how's it going, everybody? Brad the Guitarologist here. As you can see, I've invested in some new light fixtures. I have, actually, I didn't do that. These are my wife's. This one, I have another one identical to it up over here, and now I'm blind because I just looked at it. Our videos in the future should be a little bit better here at this station, so that's good. Also, I've started using a microphone, an overhead microphone, which is up here just out of sight, so it should sound a little bit different than some of my previous videos as well, and it should be in mono, so that you should hear the same thing on both sides. Whereas before we had a stereo onboard microphone on the camera, and when I moved around sometimes it wasn't so great. So anyway, so that should be slightly improved as well. I've been working on this Gibson GA15 RVT Explorer amplifier, and I had to pause in order to order some parts. So we're going to look at another amplifier that this same customer brought me. So let's turn you around and look at it. It's right down there. This is a Dean Markley KVC 60 acoustic guitar amplifier. I think this thing was probably made in the late 90s or early 2000s perhaps. I usually don't take on stuff like this. The customer who was bringing me that Gibson amplifier that I just showed said he had this thing too and wondered if I could take a look at it. So I said, yeah, what the hey, I'll look at it as long as I've got your other amp too. If it's something simple, we'll go ahead and repair it. If not, I'll probably end up sending it back to him and just giving him a diagnosis on it because, you know, like I said, this thing is probably got some IC circuits in it. I don't even know if we can get a schematic on it or not, but we're going to have to take a look and see if that's something we can locate. What does this thing have? 2 channels? It's like that top channel is 1 and channel A, and then we have a bottom channel there. And then we have phantom power, so you can plug in your microphones. It's basically like a little all-in-one jam session kind of thing where you plug in your microphone, you know, for your coffee house gigs or whatever, and then you're plugging your acoustic guitar into the other channel. We've got chorus on here. You can turn that on and off with a switch. We've got headphone jack, which I don't know how much anyone would ever use that. Got a little EQ section here. One thing that I do see, I think this has been modified. You obviously have a front facing speaker here, but if you flip this unit around, there is a speaker on the rear as well, and there's also a horn. I don't know if this is original to this amp or not. It looks like it could be, but these speakers would have to be out of phase because one is facing rear and one's facing forward. So unless they are out of phase with one another, there's going to be a problem. So we'll check that too and see if they're indeed out of phase. Go ahead and check the fuse while I'm back here. Looks like we have a foot switch for chorus and reverb. We have an effects loop, and we have a preamp out and a line out. So that would be good for recording. This is not a fuse. Okay, this is not a fuse. Okay, so inside the fuse holder, look at what we found. That is just some kind of rivet or pellet that someone has cut to size and stuck inside the fuse holder. So right away, that spells problems. Because if the fuse blew, there's a reason the fuse blew, and you don't ever bypass a fuse by sticking something like this in there, because you're just going to end up burning something up. You remember in the old days, whenever houses actually used to have fuses, people would try to bypass those fuses by sticking pennies and things like that in there, because the fuses were, you know, round and they screwed in. If you've ever been to a real old house that has never been updated, you know, dilapidated or whatever, you may see fuse boxes like that, and you know, people would try to bypass those, and the reason you never wanted to do that is because you're defeating the purpose of a fuse, which is to prevent your house from burning down. So it's the same in an amplifier. You know, basically what you're doing is you're preventing your transformer, your power transformer, or something else from burning down, essentially. when you do something like this, you just create more problems for yourself than it's worth. And I think what that's probably going to do is render this amplifier repair a no-go. But you know, since we already have it here and I've already started this video, I've already invested a little bit of time, we may as well go one step further. We'll open the thing up and see if it's going to be something worth repairing. All right, cue exciting music. It looks like neither of these speakers are original. They're both pyramid speakers. 300 watt pyramids. So these are more for like car stereo applications, really. And you can see that all the tape here on the wires, the speaker wires. You can see that tape there on the speaker wires. These are not original, and this whole thing has been kind of bodged. Well, I say bodged. I mean, it's done okay. It looks all right from the outside, which is really all that matters. But what I'm saying is, you could tell it's not from a factory job, that somebody, you know, drilled some holes and cut them out with home tools rather than this being a factory thing. You know, there's that element of it too. Are these speakers wired correctly? Have they ever been wired correctly, even from the start? Yeah, let's go ahead and pull the chassis, get it up on the bench, and see if anything is obviously burned. Okay, so here's the inside of this Dean Markley amplifier. We have, I'm not seeing anything really burned on any of these boards. Of course, I haven't dragged it all the way out yet, but I do see a missing, what looks like a missing fuse right down here. That may not be hooked up though, because as you can see, there's some terminals up here on top. There's two terminals here, and it looks like maybe in a different design of this amplifier they had a fuse here, but on this particular design perhaps they didn't. Let's see, we've got a rectifier bridge here, we've got a rectifier here, so one of those will probably, well, yeah, one of those will be for different voltages in the amp. Got voltage regulator here, we've got a couple of the big can capacitors here, a couple little power caps over here, smaller ones. We have a little transistor here in the regulator circuit, it looks like. I don't smell anything burned or anything like that, so the transformer is probably okay. We do have a lot of these plastic Molex connectors in here, kind of running everywhere, so you know, there's a possibility that one of those has come undone, or that the contacts are not secure or clean or whatever. Let's go ahead and pull this thing out. Just at this point, it's out of sheer curiosity that I'm doing this, because you know, I did not find a schematic, so that's a stumbling block. And whenever you don't find a schematic on something like this, a solid state thing with a bunch of integrated circuits in it, like this one has, like look at all these integrated circuits. To try to trace this out is going to be an absolute nightmare without a schematic, and probably is going to be a lost cause without one. But what I'm willing to do here is just check it out. I'll pull this chassis out, maybe pull the boards and see if there's any broken solder joints. We'll fire it up slowly on the Variac with an appropriate fuse, of course, and see if we can't, you know, make it fail. Alright, we've got this thing plugged into a speaker over here, and just for testing purposes for now, we've got it plugged into the Variac back here, and we'll dial it up slowly and see what we come up with. We have it on. Okay, I'm getting some noise at the speaker. Okay, I'm dialing it on up a little bit. Some oscillation there. You can hear it kind of going. It's going pop, 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 pop. So I don't know if that's because of the voltage. We'll go ahead and dial it on up to 120. I've got a 1 amp fuse instead of a 2 amp fuse in this thing. I'm only drawing 0.12 amps, so I'm way off from the 1 amp. This master volume is really dirty. The other thing I noticed about this thing, there's a lot of little bug carcasses and things in this, so there's no telling where it was stored. Maybe in a garage or something, or a shed even. But listen to that. That's the active EQ. And the graphic seems to be working okay. Okay, so that channel seems all right. Let's check this other channel. Well, we do have life, at least. Let me see how long this life lasts when we start poking around on these boards. I'm guessing that the reason we had this little pellet in there instead of a fuse is because somebody blew a fuse. Maybe it's just a fluke that they blew a fuse, there was nothing wrong with it, and so they added that. And maybe the complaint from this customer is just cleaning related, but I kind of doubt it. Seeing the state of this thing, let's flex some boards and see if anything blows. Right over here is where I would expect it to happen. Oh, something happened. Right there. Something is happening right there. When I flex the board right there at this location. It may have been because my speaker outs were, they're just a couple of gator clips. Now, something's going on right here with this transformer. Huh. Well, this is an odd one because it seems like it might be an intermittent. Something's intermittent over here. I think we probably have a bad solder joint over here on the power somewhere. And at one point it probably caused a spike, blew a fuse. So we're going to have to pull this bottom board and search for bad solder joints. And while we have these boards out, we want to make sure we also clean all these pots, because it'll be a ton easier to do it at that point. Oh my God. Somebody glued this damn pot in, it looks like. Damn it. Somebody definitely, they put super glue on the threads. That's exactly what happened. Somebody put glue on the threads on that one. It sounded like I cracked a solder joint as I was trying to get that one off. It's really the power board we kind of want to get to, but since we do have to clean this one anyway, I guess we may as well just undo these. There's the reverb lead, so I'm guessing the reverb circuit is this little chip here probably, and these surrounding components is all part of that. And we'll get a little better look at this board. Let's see what we've got going here. Okay, we're going to go to a different camera here. I've got you guys set back a little bit. We're going to put in my microscope. Okay, let's get a look at some of these solder joints. Now, these right here look particularly crusty, and I was kind of worried about this big scratch running across here. There's a big, I'm not sure if it's, I don't think it's severed that connection, but something sure got in here and scratched the hell out of it. I don't think it severed anything. Yeah, this really isn't the board that I suspect is the problem anyway. And that one though looks like it has a cracked joint. So I'll reflow that one for sure. I want to pay close attention to these potentiometer solder joints, because these are the ones that break most often. Yeah, those look okay. That one right there doesn't look too great. Yeah, see that solder joint right there? It's got like a big hole in it. Okay, so there, that one is better. That one looks okay. This one we have 6 connectors, and those all look okay. Those look alright. Those look okay. I think that's it. So this board should be good to go. We'll set it aside and pull this bigger one. I think we've got to take a couple more screws out of this larger one from the bottom. Yep. Yeah, this is one of the terminals for one side of the fuse. This is the other one, and it's completely isolated from the rest of the board. It's not even connected to anything, so. Alright. Try to get a look at what we're... Like I said, this whole power section down here is really suspect to me, and it looks like, ooh, this has been replaced before. See this? This capacitor has been replaced, and they even dropped some solder on the board right there. So I wonder if this was a problem sometime in the past. That's interesting. Let's see what's under here. Yeah, you can see what I mean. That's definitely not factory. It looks like this thing has definitely been worked on before. Somebody's been in here. You know, you can see the little scratches, and you can see where they've hit this with solder and left a little blob right there. But you see what I mean. You can see where it's been. Somebody's definitely been in here before. I don't see any bad solder joints or anything down here. Now that's suspect just because it's because somebody put it in after the fact, and I don't know, you know, who knows where that even came from. Got some, looks like oxidation here on this edge of the board. You can see it's exposed. It's eaten away some of the masking. This is the one that sounded like it cracked whenever I tried to unhook it. I'm going to go ahead and hit this one with solder just because. Put a little solder flux on there for good measure. Okay, well those look okay. They look good enough. I don't think they're going to be a problem. And there's solder like all over the place on this board. There's solder like here. There's little bits of it everywhere. So you can see it all over the place. Some there. Big scratches. Damn. This one looks like it's been hot. Seems like there's kind of a lot of dirt and crud over here on this side, like maybe something got spilled. I don't know. You see what I mean? It's just there's a lot of crud over here. So I'm gonna spray this connection. I'll clean it. Couldn't hurt. There's a pot over here that's probably for biasing the output. I'm going to go ahead and clean it as well. Another pot right here, and we'll go ahead and spray it, clean it as well. That right there, that's the output. Just came loose. So I'm wondering if that's been a problem. Okay, so I've checked pretty much all of the suspect solder joints with the microscope. And let's see, now I think what I want to do, I think I want to pop these two capacitors out of here and these two capacitors out of here and test them individually and just make sure those aren't an issue. Okay, this is a 470 microfarad. Let's see what it actually measures at. Yeah, that one's fine. 479 microfarad. Let's check a couple of these other ones. Alright, this one's supposed to be a 220 microfarad. Okay, so that one's perfectly fine too. With those being as close as they are, I kind of seriously doubt that there's a problem here. Okay, I think we're ready to again to fire this thing up. Pot's a lot cleaner. Chorus works. I think earlier what I was hearing wasn't a oscillation, it was the chorus. So the chorus is working. The controls for the chorus are all working as well. So that's good. Okay, well that channel does work, so that's an improvement. It's a lot less noisy. Still got a little scratchiness in that pot, but it's not too bad. Excellent. Well, I think the thing is fixed. Well, I thought I had this thing fixed, but now we're getting some crackling here through the speakers, and it's reverb related. I can turn down the reverb and it goes away completely, so got to get back in here and do something about this reverb. And in typical fashion, I get the thing back open and it has completely stopped. I've got the reverb cranked all the way up and this thing gets quiet as a mouse. So I don't know. That's the reverb pot right there. And everything surrounding it's probably the reverb circuit. I'd say that IC chip right there is the reverb chip. And it, I suppose could be one of those capacitors causing an issue. Or it could have just been an intermittent cable connection there. I wiggled those cables and they were fine, but you know, in the process of opening this cabinet, that pair of cables right there kind of got pulled. So, you know, it's possible that stopped it. I don't know. But whatever it is, it's gone at the moment, so I can't really can't troubleshoot something that's not creating trouble. 1, 2, 3. Love me 2 times, baby. Love me twice today. Love me 2 times, girl, 'cause I'm gone away. Love me 2 times, girl. Once for tomorrow, one just for today. Love me 2 times, I'm gone away. Love me 1 time. Love me 1 time, baby. Yeah, my knees got weak. me 2 times, girl. Lost me all through the week. Love me 2 times, I'm going away. Alright, yeah. Love me 1 time, could not speak. Love me 1 time, baby. Yeah, my knees got weak. But love me 2 times, girl. Lost me all through the week. Love me 2 times, I'm going away. Love me 2 times, babe. Love me twice today. But love me 2 times, babe. 'Cause I'm going away. Love me 2 times, girl. 1's for tomorrow, 1 just for today. But love me 2 times, I'm going away. Love me 2 times, I'm going away. Love me 2 times, I'm going away. Thank you very much.